right, here we are at the FRQ, as they say. There's 4 of these on the practice test. There's 4 of them on the real test, too, and this one is designed to look like the ones that you would see on the practice test. So the function g is graphed below. Looks like we got ourselves a nice little asymptote, stuff like that. G of x has a vertical asymptote at x equals -3. I can see it. And 2 labeled coordinates, -1, 2, and 1, 1. Additionally, f of x is defined by the function f of x equals 6 over x squared minus 9. So we got 2 different things going on. We have g of x, which looks like this, and f of x, which looks like that. Lock that in. Part 1. K of x is defined, it's also designed by me, and defined by k as f of g of x. F of g of x. So k of -1 is us trying to find f of g of 1, and let me put that as a different color. F of g of -1. Oh, that was a close one. When I made a video of these last time, I accidentally plugged in the wrong number. I got a lot of comments on it, so I almost did it again. Oops, Britney Spears would say, because she did it again. So g of -1. What is g of -1? Well, g comes from this guy, and g of -1 is 2. G of -1 is 2. So g of -1 is 2. So now I have to find f of 2. F is defined as x over x, 6 over x squared minus 9. So f of 2 is going to be 6 over 2 squared minus 9, which simplifies to 6 over 4 minus 9, which simplifies to 6 over -5. But since I'm running out of space, let's just throw the negative out there and say that that is our answer for A. So let me just wrap it up. K of -1 equals -6 over 5. Bada bing! That's A, part 1, or I. Part 2 is asking you to find all the vertical asymptotes of f of x, or indicate if there are none. F of x is given to us by that. Vertical asymptotes exists when the denominator is equal to 0. So x squared minus 9 equals 0. 2 ways you could do this. You can add 9 to both sides and square root, or you can factor this out. X plus 3, x minus 3. The zero product property has me setting each parentheses equal to 0, or as I know by now, the magic number for that parentheses is going to be -3, and the magic number for that parentheses is going to be +3. So I'm going to write out that the vertical asymptotes are x equals -3 and x equals +3. Now, I'm writing them both out because the vertical asymptotes is technically a vertical line. X equals -3 and x equals regular 3, I think would just be the proper way of writing it out. All right, so part 1, or problem 1, part A, complete. That's 2 out of the 6 parts that you're going to see on this guy. Part B, problem 1, same exact question above, don't need to repeat it. Find all the values of x as decimal approximations for which f of x is equal to -4.1. So what I need to do is I need to take that guy, and I need to find out when it's equal to -4.1, and that's going to require our calculator. The first 2 problems of the free response question are calculator problems, and I'm going to want a calculator for this guy. So let's go over there. And before I go over there, let me explain what I'm going to do. Okay, I'm going to type this first guy in to the y equals part. And so, I'm pretending that this is a TI-84 plus. And in the second line, I'm going to type this guy in and find out where these guys intersect. Now I'll go over to the calculator part. All right, let's graph these puppies. I've got my first equation being 6 divided by, make sure you put the entire denominator in parentheses, otherwise your calculator will not know what you're talking about. TI-84 plus, you're very reliable. Not joke. Now, we were supposed to solve when this guy was equal to negative 4.1. So I'm doing systems of equations stuff right here, and I'm doing negative 4.1 to the other one. When we hit graph, we're going to see a blue line and a red line cross. My gosh! Not only do they cross once, they cross twice. Who would have thought? Well, what I have to do is find out where these guys intersect. So I'm going to hit second, trace, and I'm going to hit 5 for intersect. Let's do the one on the left. So I'm going to move to the left, and I'm going to hit enter, and then I'm going to move to the right for second curve and hit enter, and for guess, hit enter. And it's going to tell me that one of my x values is negative 2.7452, blah, 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 blah. Okay, now since this was like a pretty looking denominator, and we found out that the vertical asymptotes were 3 and negative 3, we probably know what the other x value is going to be. But listen, I get paid by the second, so why don't we keep going? Let's hit second trace again to go to calc, go to 5 again to intercept, and let's find the other one. To the right, to the right, to the right. Cupid shuffle. Remember that? Remember that dance from like 2008? Hit enter again, hit enter for guess, no sign change. What did I do? All right, let's try it again. Trace, second trace. I thought I hit intersect. So, you know what? I think I know what I did. I wonder if I accidentally jumped over to that graph. This is a good mistake that happened. Enter. Let's move to the right, just barely. Enter, enter. Yeah, and that seemed to work. So as you saw, when I tried finding this one, it yelled at me and said, no, you did it wrong. I wonder if by moving right too many times, it tried to find the intersection of the red line and this part of the blue line, which there is none. So, a happy little mistake occurred. But we got what I figured we'd get, 2.745. So we get the negative version of that and the positive version of that. So let's go back and write it out. All right, so as you saw when we tried to do the graphing part, we got two of the same number basically, but one's positive and one's negative. So x equaled negative 2.745 and positive 2.745. And again, the fun thing that happened there is we had a little error pop up when we tried doing it. And it's always kind of good to play around with your calculator and see when things screwed up. And it did there, and we kind of probably figured out why. But, happy little mistake. TIs are not perfect. Not the wrapper and the calculator. If you don't know what I'm talking about, there's a wrapper named TI. That was problem I, BI. And now let's do BII. So determine the end behavior of f of x. So again, that's this guy here. As x increases without bound. Now, what does that mean? That means the limit as x approaches positive infinity. The limit as x increases without bound means x is going to keep going to the right, to the right, to the right. Cupid shuffle again. Now, if it said decreases without bound, it would be negative infinity. The fortunate thing about this is the answer is going to be exactly the same. Now, I'm not going to run to my calculator. Maybe you remember what the picture looked like, but I'm going to do this without the use of a calculator, without the picture. Okay, f of x is given to us as 6 over x squared minus 9. What you do when you're asked to find the limit as x approaches any infinity of a rational function is you take the leading term of the numerator and the leading term of the denominator and simplify it. And if you're like, it won't simplify, you're absolutely right. If the denominator's degree is higher, you're always going to get 0 no matter what. And that's because if you keep plugging in numbers, like if you plug in 5, you'll get 6 over 25. That's like point something. If I were to plug in 10, you get 6 over 100. That's going to be 0.06. Plug in 1,000, plug in 10,000, plug in 1,000,000. You're going to get a really, 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 really small number like 0. It's never going to hit 0, but it's going to be close enough where you can finally say, you know what? I give up. The limit as x approaches infinity of f of x is going to equal 0. So that's how you find out the end behavior as f increases without bound and expressing it in limit notation. So there you go. Isn't that neat? Limits. All right. Part B, Denzu. Part C. The function g is oh yeah, it's the same one. I don't need to do this. All right, so this is what g looks like. Again, we've got very similar kind of to what we just saw in F, but this one only has one, okay, vertical asymptotes. It's asking if g is invertible. Now, what does invertible mean? Invertible means, can you find the inverse? Okay, now the inverse exists if you can take what's called the horizontal line test. Now, the horizontal line test says if I were to take a line, and let's put a line there. I tried to, it wouldn't let me. Let's see if it will do it again. If I could take a line, do I have a line? I hit the button. Let's try it one more time. Can I take a horizontal line and pass it through the red graph and have it hit more than once? So, no. Now here, I have a horizontal asymptote, which means it doesn't pass the red line more than once. No. So the quick answer to this, guys, is G invertible? Well, the answer to CI is yes. Now, here's the frustrating thing about the AP exam. Part 2 is asking to give a reason. Using the phrase, yes, because it passes the vertical line test will not fly for the AP exam. Why? It just won't. Remember, if you have a regular function, okay, its inverse is when the x's and the y's swap. So what we could say is for every y in g of x, each y is mapped to exactly 1x. What that means is, if you're remembering like things like these, like what were these called? Mapping diagrams, and you were asked, this is back in 8th grade, you were asked to find out if something's a function, you would be like, no, it's not. Well, now I kind of care about it in the opposite direction, right? Well, every y is mapped to exactly 1x. Now, why does that matter here? So, when taking the inverse, right? When you take the inverse, every x in G inverse is mapped to exactly 1y. That's not how you spell exactly. Exactly 1y. So again, if I were to pick, like, I don't have points, but there was another problem that I did where I gave you points. And so if you had points like 1, 2, 2, 4, 8, 6, right? If this was g of x, and I were asked you to find g inverse of x, okay, you would say 2, 1. 4, 2. You would flip the x and the y, right? And as you can see, once I flip them, the x's don't repeat. Well, that's what's going on here. Since the y's don't repeat in this picture, once I flip them, the x's won't repeat in the picture. So that's problem 1 in my ultimate practice test. It's designed to look like problem 1 in version 2 of the practice test found on AP Classroom. Is it the same? No. Is it similar? Yes. So if you were to watch this and do that, you'll primarily get a very similar thing. Okay? So that's it. Hope this helps.